This video is on two-column proofs. We're going to be proving two sets of proofs. We're going to be doing two proofs on this video. These proofs are also called step proofs. The difference being between the last two proofs that we did, we were given all of the statements and we came up with all of the reasons. On these proofs, we are given some statements and some reasons. So we have to be very careful. Step proofs could be the hardest type because you have to follow what it says. Because if you don't follow it, you'll get mixed up with it. So we need to make sure we read very carefully on which one comes next. So as with all proofs, your first statements are always going to be what your givens are. So in this one, we have 1, 2, 3 different givens. So our first 3 statements will be givens. But in this case, because these two statements are the same, they're both perpendicular, we can write it into one statement. So our first statement, C is midpoint of segment BD. First statement, C is midpoint of segment BD. That first reason is given. The second part will be our AB. Segment AB is perpendicular to segment BD. We don't have it written in here, so we can write it. Segment AB is perpendicular to segment BD. That's given. The third statement would have been BD is perpendicular to segment DE. But because 3 is already here, we have something there which is not the same. We need to put this statement with the second statement. Because they are both talk about perpendicular, we can put them together. It's just a lot of times you will want to keep them separated. But this is why with step proofs, you have to be very careful about what you're reading. And it says that reason 2 is the given. So those are from our given. Now, before I move on to anything else, I look at my givens and see if I can write any segment congruent or angle congruent. So statement 1. It does not say anything about congruency, so I cannot write anything, an S or an A. Statement 2, I do not have congruency symbols, so I cannot write anything here. What that means is that we actually have to continue using our givens to help us figure more stuff out. So let's look at our first given. C is the midpoint of BD. So what you want to do is underline this word midpoint and circle BD, because this is what we're focusing on. I don't care about C. I want to care about the word midpoint and what it's of. So we care about this part right here, BD. So BD has a midpoint. Midpoint is a point that cuts a segment in half. So BD is being cut in half. We want to find what that gives us. So if we look at statement 3, it says that segment BC is congruent to segment DC. So BC is congruent to segment DC. Now, this entire segment BD is now split in half. That's what midpoint does. So because of midpoint in our given, we can say that these two segments are congruent because of midpoint. That's what midpoint does. That's the definition of a midpoint. So reason 3 would be definition, I'm going to abbreviate that, of midpoint. Because that's what midpoint does. It cuts a segment in half. And we underline the word midpoint. That means we have to use the word midpoint. These words match. It's just a matching words. The next statement is already given to us, so we have to use it. So angle BCA is congruent to angle DCE. So now I have another angle. Now we have to understand, we have to figure out why these angles are congruent. These angles are vertical angles to each other. So the reason these are congruent is vertical angles. vertical angles is a theorem, so that's why we're allowed to use it. Midpoint is a definition, which is why we're allowed to use it. Next, we have we don't have statement 5, but we have the reason for statement 5. So we have to read the reason to come up with the statement. Definition of perpendicular lines. If we think about what does perpendicular lines give us? Perpendicular lines give us right angles. Not congruent angles, but right angles. So we actually will have right angles. AB is perpendicular to BD. So we have a right angle at B. But we also have perpendicular here, where BD is perpendicular to DE. So we have a right angle at D as well. So we can say in statement 5 that we have these two right angles. So angle B and angle D are right angles. That's because the lines were perpendicular. Perpendicular does not give us congruency, but it does give us right angles. So I can write a little box in here for the right angles. So I'm going to go back through and see if I have, from the 3 things we've done, from the 3 pinks, if we have enough to prove. So at statement 3, I do have congruency. I have a segment congruent, so I can put an S beside it. For statement 4, I have an angle congruent, so I can put an A. For statement 5, I have an angle, but it does not say congruent, so I cannot put anything here yet. That means I got to keep going. So I've already used these 2 pinks. I got to continue using this because I don't have anything congruent from it. Now it says that angle ABC, which is that right angle, is congruent to angle EDC, which again is that right angle. Well, right angles are both 90 degrees. So if they're both the same measure, then the angles are congruent. All right angles are 90 degrees, so all right angles should be congruent. That is actually the theorem for a right angle theorem. I'm going to abbreviate theorem to THM. That's the right angle theorem because all right angles are congruent. So now I have 3 pieces. So I have an angle congruent again. I have an angle congruent, so I can put an A beside this. Now I have 3. So I'm going to come back up here. I can have angle, angle, side, or angle, side, angle because I have 2 letter A's and 1 letter S. These are the only 2 possibilities I could have. So now we look at our picture. This is why it's so important that we do mark it. My 2 angles, I have an angle here and an angle here. My side, my tick mark, is in between my 2 angles. So my side is in between them, so it should be angle, side, angle. So let's check it on this one. I have an angle mark here, I have an angle mark here. My tick mark is in between them. So this is angle, side, angle. That means that we can prove these triangles congruent. So we go to our last statement, is whatever this says, prove. So I just rewrite this exactly as it says. So triangle ABC is congruent to triangle EDC. And the reason was what we just said, was angle, side, angle. We have just proven these 2 triangles congruent. On this next proof, same type of thing. We have some statements given, some reasons given, and some not at all. The first statement and the first reason is not written for us, so we have to know that it comes from our given. We have 2 things of givens, and we have 2 statements where the second statement is part of our given. So yes, the second statement is part of our given. That means our first statement should be our given as well. So the first statement should be that segment BA is congruent to segment ED. And the reason for that is given. So I can mark that with BA is congruent to segment ED. You can mark it with tick marks. Then statement 2 comes from your given. C is the midpoint of segment BE and segment AD. That is the exact same thing written. So reason 2 is given. That's all of our given. So now I'm going to go through and see if I have anything I can write. I have on statement 1 a segment congruent, so I can put an S. On statement 2, I have segments, but I don't have congruency, so I cannot put anything beside here. So I have to keep going. What that means, so the first statement was done. I don't have to do anything else with that because I was able to put something beside it. I was able to put an S or an A. But statement 2, I couldn't. So I have to go back to this. I see a word midpoint. I'm going to underline that word midpoint. I'm going to circle BE. But I also have AD, so I'm going to underline midpoint again and circle AD. So I have to focus on both of those. And then we have the information down here. So statement 3 is given to us in our proof already, so we need to use it. We're most likely going to be using this word midpoint because it's in our given, so it's going to be in here in our proof. So it says that segment BC is congruent to segment EC. Now, BE is the entire segment. And in our given, it says that BE, we had BE, but C was the midpoint. Midpoint is what cuts a segment in half. And that's what happened here. BE was cut into 2 smaller segments. So this was the midpoint. That means that the midpoint made this little segment and then this little segment, and they're congruent to each other. So the reason is the definition of midpoint. We're going to use that midpoint again. Now I have a congruent segment again, so I can put S to the side because this is a segment congruent. But I still need one more. So we go down to, in our proof, 4. Well, we already have the reason, so that means we have to be very careful about this. We have to use the reason to get our statement. It says we're going to use midpoint again, definition of midpoint. That means we have to find another midpoint. Segments congruent because of midpoint. Midpoint will always give you segments congruent. So we already used the BE, so we have to use AD. We go to AD, and AD needs to be cut in half into 2 smaller segments. What that means is A to C is one of our segments, and then D to C is our other segment. So we can mark those congruent. We would say that segment AC is congruent to segment DC because of the definition of midpoint. I have congruent here, so I can write out this is a segment congruent, so I can put an S. Now I have 3 S's. The only thing we could prove is side, side, side. This is a side, 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 and I have the same amount of tick marks. That means that we can write our final statement, that the triangle, whatever our proof says, triangle ABC is congruent to triangle DEC. That's the exact same thing the proof says, what we write here. The reason for these triangles to be congruent is side, side, side. S, S, S. This is a postulate, so that's why we're allowed to use it. We have just proven these 2 triangles congruent. There is another way to prove these congruent. You could also have used vertical angles, but if you find from your information that you can prove these congruent with side, 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 you can do that. We did not have to have that BA is congruent to ED. If we didn't have that, we still would have been able to have proven these congruent by using vertical angles, and we would have had side, angle, side. So proofs aren't always just one way of doing it. Sometimes there's multiple ways. It's whatever you see and whatever makes sense the most.